This quiz challenges you to test your knowledge of the new and tall hyperparameters within the SGDOneClassSVM algorithm from the Sklearn library, which is used for anomaly detection. We'll explore how these parameters impact outlier detection in the model's training process. This question presents 4 statements about how changing the values of new and tall affect SGDOneClassSVM's behavior. I'll help you understand each statement and determine its accuracy based on the algorithm's functionality. Let's dive in. This statement is true. The hyperparameter nu sets an upper bound on the fraction of training data points that the algorithm will classify as outliers. Increasing nu raises this upper bound, allowing more data points to be flagged as anomalies. This statement is true. Tolerance defines how much error the algorithm will tolerate before stopping its training process. A smaller value demands a higher level of precision, resulting in more iterations to reach convergence. This is false. While nu influences the number of support vectors indirectly by setting a lower bound, it doesn't directly determine the exact number. The actual number of support vectors depends on the model's fit to the training data. This statement is false. The tall parameter only affects the training process, determining the accuracy of the final solution by setting the precision required before halting the iterative optimization. It does not change the algorithm's capacity to detect outliers. I'm introducing the relationships between the hyperparameters nu and tol in the SGDOneClassSVM model. I'll explain how each one affects the model's behavior. This parameter controls the upper bound on the fraction of training errors and a lower bound of the fraction of support vectors. Think of it like this. A higher nu means you're okay with a larger portion of your data being labeled as outliers, potentially increasing the number of outliers you detect. I'm going to discuss how nu impacts the model's sensitivity to outliers. This parameter sets the tolerance for the algorithm's stopping criterion. It's like setting a goal for how precisely you want the model to be optimized. A smaller TOL value means you want a more precise result, requiring the algorithm to run for more iterations to achieve convergence. It does not directly impact outlier sensitivity. This just affects how efficiently the model trains. I'm analyzing the hyperparameters nu and tol used in the SGDOneClass support vector machine SVM algorithm for anomaly detection within Sklearn. I'll focus on how these parameters affect outlier identification in the model's training process. It's like tuning a radio. Nu and tol are the knobs we adjust for optimal performance. I'm looking at the nu parameter. It controls the upper bound on the fraction of training errors and a lower bound on the fraction of support vectors. Think of it as setting a limit on how many data points the model can classify as outliers. A higher nu value means it is more tolerant of errors and identifies more outliers. It also influences the model's margin of separation between normal and abnormal data points, indirectly affecting sensitivity. The TOL parameter sets the tolerance level for the algorithm's convergence. It's essentially the level of accuracy the model needs to reach during training. A lower TOL value means we demand higher accuracy, leading to more training iterations as the model strives for that precision. It improves accuracy but takes longer. It doesn't directly change outlier detection, just how precisely the model trains to find them. I'm analyzing the hyperparameters nu and tol used in the SGDOneClassSVM model for anomaly detection. This is a crucial part of understanding how this machine learning model works. This is the main question, focusing on understanding how the hyperparameters nu and tol affect the behavior of the model for anomaly detection. I'm going to evaluate each statement carefully to see if it's correct or not. This statement is false. Nu doesn't directly determine the number of support vectors. While nu influences it, the precise number of support vectors is ultimately determined by how the model fits the data and which data points it considers crucial. Think of nu as setting a range. It doesn't pick the exact number. This statement is incorrect. The parameter tol is about the model's training process, not its sensitivity to outliers. TOL sets how accurate the model must be before it stops training. It doesn't directly make the model more or less sensitive to outliers. That's nu's job. This statement is true. The hyperparameter TOL controls how precise the model needs to be before it stops its calculations. A smaller value of TOL means the model will keep training for more iterations to reach a higher level of accuracy, which means more computational time. This is also a true statement. The hyperparameter NU controls the upper bound of the fraction of training errors and the lower bound on the fraction of support vectors. If I increase NU, I allow for a bigger fraction of points to be classified as outliers, thus increasing the number of identified outliers. I'm focusing on the NU hyperparameter in SGDOneClassSVM. It's really important because it directly impacts how many data points the model labels as outliers. A higher NU means more potential outliers. The other crucial hyperparameter is TOL. This one's about the model's training process. A smaller TOL value leads to more iterations during training, aiming for greater precision and potentially a better fit, but at the cost of additional computing time. This section focuses on understanding the hyperparameters (new) and (tol) within the SGDOneClassSVM model, a type of machine learning algorithm used for anomaly detection. We'll explore how these settings affect the model's behavior. I see that (new) sets an upper limit on the fraction of training points labeled as outliers and a lower bound on the fraction of support vectors. Think of it like this. A higher (new) means you're more willing to accept a larger fraction of the data points as anomalies. It influences how sensitive the model is to outliers, how easily it flags them. The (tol) parameter, or tolerance, controls when the algorithm stops training. A smaller (tol) means the algorithm will keep going until it achieves a very precise solution, even if it takes more time and iterations. It doesn't directly impact how many outliers are detected but affects how efficiently the model finds them. It's all about precision versus computational cost. This question's focus is how (new) and (tol) impact the performance of SGDOneClassSVM, a support vector machine variant for one-class classification, detecting anomalies. I want you to remember that (tol) only influences the training process of the algorithm, not its sensitivity to outliers. That's the job of (new). I'm analyzing the hyperparameters NU and TOL, used in the SGDOneClassSVM, stochastic gradient descent one-class support vector machine, algorithm for anomaly detection. This is a machine learning technique to identify unusual data points. I'm tackling a multiple-choice quiz about these hyperparameters. The quiz will test my knowledge of how NU and TOL affect the algorithm's behavior. I'm focusing on the TOL, tolerance, hyperparameter. This parameter controls when the SGDOneClassSVM algorithm stops its iterative training process. A smaller TOL means I require more precision. The algorithm keeps going until it reaches a tighter convergence criterion. I'm looking at the NU hyperparameter. It sets an upper bound on the fraction of training points all allowed to be labeled as outliers and a lower bound on the fraction of support vectors. A higher NU value allows for more outliers in the model. I'm using the SGDOneClassSVM from the Sklearn library. This is a powerful tool for detecting anomalies in my dataset. Increasing NU means I'm raising the limit on the proportion of data points considered outliers. So, I expect more outliers to be identified. The TOL parameter sets the tolerance limit. A smaller TOL means I'm setting a stricter convergence standard, so the algorithm will run for more iterations before stopping. This statement is incorrect. NU doesn't directly determine the number of support vectors. It only influences it indirectly by affecting the model's margin and the number of outliers considered. This is incorrect. The TOL parameter affects the training process, the number of iterations, not the model's sensitivity to outliers. That is controlled by NU. I see that NU is a hyperparameter in SGDOneClassSVM. I understand that it influences how sensitive the model is to outliers and sets an upper bound on the fraction of training errors and a lower bound on the fraction of support vectors. A higher value means the model is more tolerant of outliers. This refers to the tolerance parameter, TOL. I understand that it controls when the algorithm stops iterating. A smaller TOL means the algorithm will run for more iterations to achieve a higher level of accuracy before it stops. It's all about the precision of the model's optimization. It does not directly affect how many outliers the model detects. This question asks about the effects of the hyperparameters and TOL in the SGDOneClassSVM model used for anomaly detection. The title simply states that this problem focuses on analyzing the two hyperparameters, and TOL, within the context of SGDOneClassSVM.